let's say we would like to find the equivalent resistance of a complex network. How do we go about doing it? So in this example, let us try to find RAB, which is the resistance between node B and node A, and it's the equivalent resistance of this complex network of resistors. We don't know what's exactly in parallel and in series, so let's try to break it down in a systematic manner. So one way to go about doing this is to enumerate the nodes, identify them, and then see what's connected to what. So let's just identify the nodes. So I'm just going to use different colors. So here's one node over here. Okay, these are all connected. That's one node. And here's another node here. This one is a pretty complex one. It goes down to here, goes up here, goes here, and across, and down to here. So that's another node. And let's see, here's a node here. Okay. And then let's see, we have one more node, and that's this one, all the way across to here. This one, this, and this. So those are all the nodes. There are 1, 2, 3, 4 nodes here. Okay. So let's number the nodes just so that we can identify what's what. So let's call this node node 1. Okay, let's just identify this one as node 2. Okay, and we have a connection point on the other side here. So let's call that node 2 as well, just so that we don't get confused later. It's all the same node. Okay, and then let's call this one node 3 and this one node 4. Okay, and we can notice that node 1 is node B, and that node 3, let's call that node 3 here so that it's not confusing. Node 3 and node 8 are the same. Okay. So now let's redraw this circuit in a way that we can identify what's in parallel and what's in series. So let's start off with node 1. So let's say we got node 1 here, and we know that that's node B, right? So now let's identify node 2 and see what's connected between them. So so let's look at R1. So we have R1 here, and it's connected between node 1 and node 2. So let us draw that, and let's go in blue. So we've got an R1 between node 1 and node 2. So that's R1. And let's just cross out R1 so that we know we've done it. And let's move on to R2. So we can see that R2 is connected between node 1 and node 2. So let us show that. Oops. Let's use the same color. So between node 1 and node 2 we have R2, and then let's scratch that one out and go on to the next resistor, and we see that R3 is connected between node 1 and node 3, so node 1 and node 2. So let us write R3 as well. Okay, so those ones happen to be connected in parallel. Okay, let's go to a different node. So let's go to node 3. So let's identify node 3 here, and let's see what's connected. So between node 2 and node 3 we see an R6. So then let us put R6 between there. Okay, and we don't see anything else connected between node 2 and node 3. Okay, fair enough. Let's get rid of this line here. And then let's move on to another part of the circuit. So let's do node 4. So let's just put node 4 down here just for fun here. don't really know exactly where to put it, but we'll see what's connected to what here. So we can see that between node 2 and node 4, we have an R4. So between node 2 and node 4, we have an R4. Okay, let's scratch that one out to say we've done it, and we did R3, so let's get rid of that one. And then what else do we have? Oh, we did R6 as well in the previous step. So now between node 2 and node 4, we have an R5. So let us connect that one too. Between node 2 and node 4, we have an R5. So that's R5. Okay, we've done that one. Okay, what's remaining? Okay. Look, between node 4 and node 3, we have an R7, so we have node 4 and node 3 here. So let us put R7 in between. So that's R7. And then what else do we have between node 4 and node 3? We have an R8. Okay, we also have R8. So we've done those two. So we've done R8 and R7. And now we have an R9. Okay, so what's happening with R9? R9 is connected to node 3 on either end. So there's node 3. It's all node 3 up here. So we have an R9. Oops, let's use the same color. We have a R9 connected to node 3. So it's connected to the same conductor, so it's shorted out, but let's just denote it. That's R9. And we're going to know that that's shorted out, so it's not even part of the circuit anymore. So we've covered everything. And node 3 is also node A, so let's not forget that. That's node A. Okay, so now we can see this circuit in a little bit more clear way. And let's identify all of the parallel branches and simplify the circuit in a drawing, okay? So let's redraw this, and let's go down here. So between 1 and 2, we've got a resistor, and that resistor value is going to be the parallel equivalent of R1, R2, and R3. So let's just denote it like this: R1 in parallel with R2 in parallel with R3. Okay, so then it goes to node 3 through the series resistor R6, and then down here in parallel we have this R4 and R5. So let's just drop down, and we have this parallel resistance here that goes between what it looks like R2 and R4. So I was a little aggressive in drawing that, and that goes to node 4, and that resistor is the parallel equivalent of R4 and R5. And then we have parallel equivalent of R7 and R8 down here. Okay, and that is R7 parallel R8. So that's making it a little bit more visible. So remember, node 1 was B. Node 1 was B, and node 3 was A. So that's A. So we want to find the equivalent resistance between these 2 points. So that goes like that. So now we see that this resistor is in series with these resistors. So now we can see that these 2 resistors, R7 parallel R8 and R4 parallel with R5, is in parallel with R6. And all of those are in series with the parallel combination of R1, R2, and R3. So we can write our equivalent resistance RAB as equal to parallel combination of R1, R2, and R3 plus, because this branch is in series, with the parallel combination of R6, so that's in parallel, with the series combination of these two resistors in parallel. So that is R7 parallel R8 plus, because these two are in series, R4 parallel R5. So that is the parallel combination, or the parallel series equivalent resistance for that entire network right there. Okay, hope that helps.